Good morning, all of you. In the last session, we had discussed Norton's theorem. Okay, so how Norton's theorem to apply in electrical network that we had seen in the last lecture. Various steps are there for dependent as well as independent source to apply a Norton theorem. That we have already seen some example based on Norton's theorem. Today's session will discuss maximum power transfer theorem. Okay. So maximum power transfer theorem is very important regarding your examination. So I'll share the screen and we'll start the today's session, that is a maximum power transfer theorem. Okay. This is our last theorem. From next lecture we'll see the magnetic circuit. My screen is visible. My
Yes,
screen is
sir.
visible.
Yes, sir.
So now we will see the today's session, that is a maximum power transfer theorem. Maximum power transfer theorem. First of all, we'll see what is the statement of maximum power transfer theorem. Okay, power transfer theorem. It states that the maximum power is delivered from source to load. Okay, maximum power is delivered from source to a load when load resistance is equal to the source resistance. This is a statement of maximum power transfer theorem. Okay, suppose if you apply a 50 watt volt, 50 watt source to apply at the input side. Similarly, you will get a 50 watt at the output side. Okay, whatever you have to apply at the input side, same you will get at the output side. Okay, means that time your maximum power transfer theorem will be satisfied. Means your maximum power transfer theorem, your load resistance is always equal to the source resistance. Means at the input side 50 watt is there, and at the output side you will get 50 watt. Means your input resistance is equal to your output resistance. Means we called as a load resistance is equal to your source resistance. Okay, this is a simple statement of maximum power transfer theorem. Okay, the maximum power is delivered from source to a load. Okay, when the load resistance is equal to your source resistance. Load resistance is equal to your source resistance. That is your RS is equal to your RL. Load resistance is equal to your source resistance. This is a very important statement for the maximum power transfer theorem. Okay, then how maximum power transfer theorem is applied to the electrical network, that we'll see one by one. What are the steps are there for finding out the maximum power transfer theorem? Okay, suppose we have an electrical circuit over here. That electrical circuit we have some voltage. Okay, we have a load resistance over here. That is your REL is equal to your RTH. This is your RTH resistor. The current flowing through this circuit is, suppose we assume is IL. We assume here point A and point B over here, and the voltage is VTH. So what are the steps are there? As per the statement, what I told you people, the load resistance is always equal to your source resistance. Okay, whatever power is delivered from the source, that same power you have at the load side. Okay, same power you have achieve at the load side. Okay. Then what is the step number one? That steps we'll see first upon for the independent source. Okay, for the independent source. Suppose if you some electrical network you have, and then you calculate what is the maximum power is there, and at the load side, and you have to calculate what is the load resistance. If load resistance is there in electrical network, you have to remove that load resistance. Okay, that is step number one. That is very important step. You have to remove the variable, load resistor. Remove the load resistor RL. That is very important step. Step number one. Okay. We, load resistor is there that we have to remove. Okay, that is step number one. So now the step number two is what we have to find out the what is the open circuit voltage. What is the open circuit voltage? Means you have to find out open circuit voltage. That open circuit voltage is nothing but your VTH. Okay, open circuit voltage is nothing but VTH at the open side terminal. Suppose at the open side terminal, suppose we have assume a point A and B. That is step number two. We have to calculate what is the voltage across at the open terminal point. That is point A and B. That we have already calculated how to calculate VTH at the open circuit in Thevenin theorem. Okay. The step number third is what? Find your RTH. Find RTH. How to find out RTH? We have to remove. Already we have removed a point. Your load registers RL. Okay. For finding out RTH, all independent source is turned off. All independent source is turned off. Okay. So finding out RTH, you seen from point A and B, and you can easily calculate uh, RTH. Okay. So now step number fourth is what? Find the resistance RL. Find resistance RL for maximum power transfer. Okay. For maximum power transfer. For maximum power transfer. That is RL is nothing but your what? RTH. You have already calculated RTH in the step number third. That RTH is nothing but your RL. Okay. So now step number fifth is what? Step number fifth, you find the maximum power. Find maximum power. So find the maximum power is very important step. For IL is equal to what? That is your VTH divided by your RTH plus your RL. Is nothing but your VTH divided by your RL is nothing but already RTH. Okay, means that we can write 2 RTH. For maximum power transfer theorem, you know that how to calculate power. That is power is equal to I square R. Okay, that is power is equal to I square R. That is P max is equal to your I square L divided multiply by your RL. So if you put up this value, then you will get that is VTH square divided by your 4 RTH. This is very important that you have to keep in mind the steps for calculating Pmax. That Pmax is nothing but your VTH square divided by your 4 RTH. Okay, these are the steps for applying maximum power transfer theorem for independent source. For a mixed source or control source, the difference for calculating RTH is somewhat different. Okay, same way you have to calculate VTH for control source. Okay, you have to remove the load resistors RL, and you have to finding out voltage across point A and B. But for calculating RTH, the somewhat the steps is different. For calculating RTH, whatever open circuit at the load registers, that we have to short circuit. Okay, that we have to short circuit it. Whatever the open circuit at the input at the load registers, that you have to short circuit, and from that short circuit you have to calculate your short circuit current. Your short circuit current. If you're getting short circuit current, you will calculate RTH. How to calculate RTH? That RTH is nothing but your VTH divided by your IN. That VTH you have already calculated in step number 2. Okay. Then IN you have calculated for the short circuit current. Then you can easily get the value of RTH. But for mixed source, for calculating RTH, don't turn off the sources. Okay. Don't turn off the your sources. All sources it should be turned on. All sources it should be turned on. Right. This is a for mixed source. It is clear difference between your independent and mixed source. How to apply a maximum power transfer theorem for independent as well as the mixed source. For mixed source, open circuit, you have to short circuit and you have to finding out the short circuit current. But that time, don't turn off your voltage source. Voltage source, it should be turned on. Okay. For calculating RTH is nothing but your VTH divided by your IN. The steps are clear. Is there any doubt in that? Yes.
Yes, sir.
Is there any doubt?
No, sir.
You have doubt?
No,
No,
sir.
sir.
Clear?
Yes,
Yes,
sir.
sir.
Clear or not? No. Yes. Yes, I am saying ki you are clear and you said no.
No, sir,
See,
it's
it is
clear.
clear, na? Then, yeah,
हाँ
then
सर हो
we'll
गया.
move on our example. Okay. So the first example we will see independent source. Okay. So in that example, our aim is for the value of resistance RL. Okay, for the value of resistance RL in figure, for maximum power transfer and calculate maximum power. For maximum power transfer and calculate the maximum power. That is our aim. Okay, our aim is what you have to calculate the maximum power. Okay, and the value of your load resistors RL. That is the aim. So I'll draw the circuit diagram here. Okay, that is 6 ohm. This is your load variable load resistors RL. This is your 2 ohm, 3 ohm, 4 ohm. Voltage there 72. So now our aim is what to calculate first VTH. Okay. So step number one is what VTH to calculate VTH. So how to calculate VTH as per our statement or as per the steps to apply a maximum power transfer. Whatever variable resistors are there in the electrical circuit that we have to remove out. That we have to remove out load resistors. Here load resistor is what? Your RL. Okay, load resistor is your RL that we have to remove out. Okay, suppose we have removed out again. It is necessary to draw again. Yes, it is understood or I'll draw again. So I'll draw again. No issue. Not even response. So here point A and B we have drawn again. Okay, this is your 3, 4 ohm, 2 ohm, and 6 ohm. Okay, your 70 volt. Okay, this is your VTH. At the output side, we have to remove the load resistors RA. Okay, just you have to assign the polarity. Suppose here I assume positive to negative, here positive to negative, here from positive to negative. Okay, okay, here from positive to negative. Okay, suppose I assume here this is the first loop, the current flowing to first loop is I1. But this side is open circuit, means there is no current flowing at this loop. Okay, means here we have assume again the current I2. Here is open circuit, we are not assuming any current because current should be zero in that. Okay, so now apply KVL to mesh 1. So KVL to mesh 1. So apply KVL to mesh 1. What is KVL at the mesh 1? That is 72 minus your 6I1. Okay, then this is your 3 ohm resistor, that is current from positive to negative, that is 3. But this 3 is a common between I1 and I2. Both the current is clockwise direction, means that is the minus sign. I1 minus I2 is equal to. This is your KVL mesh 1. Okay, so you have to simplify this. That I simplify that I1 minus 3 I1, that is plus 3 I2. Okay, 72 as it is, you have keep it outside, is equal to that positive sign will get negative and negative sign will get positive. Means here plus 6 I1 plus 3 I1, you will get 9 I1. Okay, 9 I1. That minus sign will get plus sign will get negative here, means 3 I2. This is your equation number 1 you will get if you apply the KVL at mesh 1. Okay, similarly you apply KVL at the mesh 2. KVL to mesh 2. KVL to mesh 2. Suppose if you starting from 3 ohm resistance, that current is from positive to negative here. Okay, so you'll get minus sign here, minus 3. That is the common between 2 and 3, 2 and 1, that is minus I2 minus I1, I2 minus I1, minus again current going through a 2 ohm resistor, that is 2, I2 minus the current flowing through a 4 ohm resistance minus minus 4 I2, I2 is equal to, you solve this and you will get, you simplify this, that minus 3 I1 plus 9 I2 is equal to, okay, that these two equations you will get if you apply KVL at 1 and 2. Okay, mesh 1 and 2. Solve the equation number 1 and 2. Solving, solving equation 1 and 2. Solving equation 1 and 2. Then what is the value of I1 and I2? Tell me.
I1 is 3 ampere, I2 is 9 ampere.
I1 is 9 ampere. No?
Yeah, yeah. I1 is
Yes,
9
agree.
ampere and I2 is 3 ampere. Sorry.
Yes, yes. I1 is 9 ampere and I2 is 3 ampere. Yes, exactly. Okay, then you get it I1 and I2. Then what is our aim? Our aim is to calculate VTH. Okay, so writing equations or writing a VTH equation at the open side terminal at point A and B here. Where is A and B? Here. Suppose we are doing here point A and B. So writing a KVL VTH equation here, writing VTH equation. So if you're writing a VTH equation here, VTH minus 6 I1, okay, minus 2 I2 is equal to 0. So you will get VTH is equal to here, that is 6 I1 plus 2 I2. So I1 and I2 you already calculated, that is 9 and 3. Just you have to put up over here and then you will get VTH. What is VTH?
60.
60 volt.
60 volt. Yes. VTH is your 60 volt. That is way we have calculated VTH. Okay. Similarly way, the step number 2, are you getting these steps all? Have you write it? Shall I move on next page? Shall I move on next page?
Yes, sir.
Yes.
Yes. Yes, sir.
Then we the step number 2 is what? Step number 2, calculation of RTH. So already I discussed for calculating RTH, you turn off all the sources. You turn off all the sources and whatever load registers you have open, you have keep it as it is. Okay, you have keep it as it is. Our aim is what for calculating ATA, RTH, turn off all the sources. Turn off all the sources. Okay, and you have calculated total resistance of the circuit. So now I'll draw again the diagram. This is the statement for independent source only, yeah? Not for dependent. Dependent we already discussed, that we'll see in the next example how to calculate RTH in dependent variable. Okay, load registers we have open as it is, there is no issue. That is point A and B with RTH. Your 6 ohm resistors, 2 ohm, 3 ohm, 4 ohm. Okay, so now this is your voltage source that we have short circuit over here. It's turn off. Okay, so now you have calculate the total resistance of this circuit. So now this is 6 and 3. Okay, 6 and 3, the current are dividing over here, means that 6 and 3s are parallel combination. Okay, this is the parallel combination, 6 and 3 are parallel combination. That 2 is connected in series again. This is 2 is connected in series, but 4 resistance again current is divided, that we assume as a parallel combination. Okay, that way, that is point A and the point B. Okay, that is your RTH. This is your 6 ohm. This is your 3 ohm are parallel with series with 2 ohm resistors are parallel with 4 ohm resistors. Now tell me the what is the value of RTH? Manish Jadhav. Manish Jadhav. Are you hear me, Manish Jadhav? Manish Jadhav. Are you hearing me, Manish Jadhav? Who is Manish Jadhav? Manish Jadhav. Mahesh Deshmukh. Mahesh Deshmukh. Mahesh Deshmukh. Manish Jadhav is there. Manish Jadhav. Manish Jadhav. Mahesh Deshmukh. So what is RTH value? Disha. Disha. Then the 6 ohm, 6 ohm parallel with 3 ohm, that is series with 2 ohm and again parallel with 4 ohm resistor. So you will get RTH is 2 ohm. RTH is 2 ohm resistors. Now the step number third, Step number third is what? To calculate RL or calculation of RL. Calculation of RL. So we have already calculated RTH. That is RL is nothing but your RTH. Okay, RL is nothing but your RTH. RTH you have already calculated. That RTH is nothing but your RL. So now step number fourth is what? Step number four. Step number four, calculate your maximum power. That is calculation of P max. P max. So what is the Pmax formula that we have seen already how to calculate Pmax? That is Pmax is nothing but your, that is Pmax is equal to, that is Vth square divided by your 4 Rth. Vth you have already calculated, that is 60 square divided by your 4 Rth is nothing but your what 2. So you will get 450 watt. 450 watt. That is your maximum power is there at the output side. That is Pmax. Pmax is equal to 450. That way you have find out Vth, Rth, RL and Pmax. Okay, these steps are clear to you people. Yes,
हेलो सर. हेलो
yes,
सर. आरटीएच का
yes.
नहीं
Tell me.
समझ. आरटीएच का 2 होम कैसे आए?
Huh? Which
आरटीएच सर.
step number?
स्टेप नंबर 2 सर.
RTH 2.
सर हाउ.
So how to calculate RTH? Tell me. Yes.
सर 2 पॉइंट कुछ आगे आ रहा है मेरा.
2 point something आ रहा है ना, that is right. So we take the sampling actually 2 ohm. It is fine. 2 point something, it is right. No issue.
ओके सर.
What the answer you get it? 2
सर
point?
2.36.
Yes, fine. Then we will take 2 ohm. That is not a biggest issue. Okay.
ओके सर.
It is applicable. It is applicable. No issue. Yes.
Sir,
Then we
second
took
step
here
में
only sampling.
sir resistors are parallel to short circuit. Then why there is a value?
Where is this? This is 2 ohm resistor here. Which open circuit? Which resistor you are saying?
सर
Yes.
वोल्टेज सोर्स को शॉर्ट किया तो बाकी सब रेजिस्टर्स उसके पैरेलल हो गए ना.
नहीं ना, यहाँ पे कनेक्शन कैसा है, यहाँ पे शॉर्ट सर्किट किया है, लेकिन ये 6 ओम और 3 ओम हम लोग को क्या करना है, कैलकुलेट टोटल रेजिस्टेंस कैलकुलेट करना है, राइट. टोटल रेजिस्टेंस कैलकुलेट करते समय आपको जस्ट देखना है कि कौन सा सीरीज में है, कौन सा पैरेलल है. दैट्स इट. समझ में आ रही बात?
ओके सर.
हेलो. यहाँ पे क्या हो रहा है,
यस सर.
हम लोग का 6 और 3 क्या है, पैरेलल. यहाँ पे आपका सपोज आप एज्यूम करोगे कि करंट डिवाइड हो रहा है, यहाँ पे 6 और 3 आर पैरेलल. 6 और 3 पैरेलल विथ योर व्हाट 2 ओम सीरीज रेजिस्टेंस. अगेन 2 ओम रेजिस्टर्स आर पैरेलल विथ योर 4 ओम रेजिस्टेंस. स्टार डेल्टा कनेक्शंस आपने पढ़ा है ऑलरेडी वीडियो बनी है, राइट? यस
यस
और
सर.
नो?
Yes, sir.
Yes, sir. Yes.
That same method you have applied स्टार डेल्टा वाला, यहाँ पे स्टार डेल्टा वाला ही अप्लाई करना है आपको। सपोज ऐसा सर्किट है, ठीक है?
Yes, sir.
Yes or no? Have you understood or not?
Yes, sir. Yes.
Hello.
Yes, sir.
Okay. Then we'll. Yes. Then we move on our next example. That is for dependent source. Okay. For the network shown in figure, you have calculated or you have calculate calculate the maximum power that may be dissipated in load register RL. That is minus plus 2ix. What is your RL? Fine. Okay, then the aim is what? You have calculate the maximum power. Okay, that may be dissipated in the load registers RL. Then you have the step one, you have calculate VTH, then RTH, then RL, and then you have to calculate Tmax. Okay.